Alright, make sure I'm live. Alright guys, thank you everyone for joining me. Looking currently at the NAM right now. Let's look at the NAM, the 12Z NAM. So it should be, 18Z should be coming out pretty shortly. I'll be streaming until 5 p.m. then I have to go. That'll be just in time for the 6Z and the 6Z NAM to come in, and part of the 6Z GFS, the important part. So as you can see, trending further north. A lot of the models are trending further north. However, the Canadian model has been trending further north as well. I mean south. Let's look at winter probabilities. Let's compare 3Z to current run. Let's look at probabilities of 8-inch or greater snows. So New York City is right on the edge of the 40 to 50%. Let's look at 9Z. Basically a little bit further north with the 9Z, but now let's look at the European, actually the current European run. Let's look at surface and precipitation. Let's look at not southern New England, we're going to go to regional now, mid-Atlantic. This is where we want to look at. Hour 48. Let's compare, actually 72. This is from last night. Let's look at, compare last night's run to current run. So you have 1,008. Right? What I notice is that the storm looks slightly different. So let's look to hour 78. Very strong storm over Del Mar. So, okay, hour 72. Are we going to have this? Yes, we are. We are going to have this system basically being right near the coast. So what does this mean? What does this mean? It means you're likely going to have very heavy snows. So you're having northeast winds coming into New York City. So you had more of an easterly component. Here you're having more of a northeast component. So let's look at surface temperatures. New York City, about 35 degrees. This is when we could zoom in. So right in over New York City, about 35. Right now, current run has, 30 degrees. And let's look at 6-hour QPF. Nothing too crazy. But now, hour 84, boom. Or actually, let's go to 72. So you're having storm is slightly slower. So let's go to hour 84, or 78 actually. Oops. A little bit further south. So you're going to be having really heavy snows just to the north, and you're having a bit of a dry slot coming in with the European. So let's look at last night's run, or yesterday's run. So a little further south again. Last night's run compared to this one. Further south. Let's look at total QPF, about 1.5 inches. The European run has definitely reduced the amount of precip that it's forecasting. Let's look at total in terms of the snowfall to water ratio. So it's showing a decrease. Also, it's a little further south, so you're showing a weaker system. A lot can still happen because you're going to have coastal bands setting up. You know, you're having a very dynamic system because you're having energy from a low here, transferring its energy here. So let's go to hour 60. Let's add the Kuhera. Kuhera is more accurate. Kuhera is more accurate because it actually shows snowfall water ratios. For example, here, see how it shifts. Here you're having 3 inches. Right here we have 1.6. Now you're having 3.2 because you're having colder temps aloft here. So now let's look at let's look at last night's run. Hour 72, right? 6.5 or 9.2. Let's look now. Let's see further south. So Kuhera 3.5 now. When last night's run had it at 6.5, so you're having actually more snow with Kuhera. So you would think, oh, we're getting less snow, but you got to look at the dendritic growth zone. Look at that, 12.8. You're not going to have 12.8 this time. See, 5.6. So now let's add 12Z, 3.9 inches. So what is it showing? It's showing heavier snow here. How accurate is this? Let's look at precipitation. Let's look at surface moisture precip. Pretty unlikely if you ask me, because look, you're having a strong surface low here. You're probably going to have a lot of moisture coming in to the system. I mean, this could be pretty likely. I mean, you're usually going to have very heavy snows. All in this area, you're going to have very heavy snow. So the position of the low might be accurate, but not so much with precip. You want to be very careful when you forecast precipitation, because when you look at total QPF, it's showing 1.7 inches. And that's from about now, so 0.3. So don't count for tonight. So let's count it for tomorrow, right? So that's about 1.4 inches of QPF. And see, Long Island has more. So let's look at winter weather. Let's look at 10-1. Let's look at Kuhera now. See, 14. So when you look at this Kuhera method, you're having a lot less snow along the coast because you have warmer temperatures aloft, which significantly lowers how much snow you might be getting at the surface, because the snowflake composition is different. For example, look at this. 6 inches for Nantucket, and with Kuhera, boom, you're only getting nothing. That's actually the more accurate snowfall forecast. This actually is more accurate than using 10-1. Why is it more accurate? Because it factors in such as warm air intrusion at mid levels, at the dendritic growth zone. Dendritic growth zone are temperatures between -10 Celsius and -20 degrees Celsius, or 15 degrees Fahrenheit to -4 degrees Fahrenheit. And the thing is, say you have a warm layer aloft, that's going to cut down on your snow totals, and that's what the European is forecasting. So the European is forecasting New York City to get between anywhere from 8 to 18 inches. So, but basically, you could say a general 8 to 14 should be expected for New York City, and that is if this model verifies. You have so many different models, but the European is usually the most accurate. Now let's look at the UK Met model. What is this model showing? Okay, that's last night's run, right? Let's look at 6-hour QPF. Let's go to hour 72. So it's showing slightly heavier precip at hours 60, but let's look at 66. So again, it's to the south. So this model is showing most of this heavy stuff will be to the south. So let's look at the system here. So you're having a very strong system, so you might have a lot of snow on the north side. But this model is saying that it could be going further south. Because let's look at hour 78. A lot further east. Let's look at total QPF. See, 1.3, showing very little precip, like almost nothing. It's literally showing only an inch of total precip. But Eastern Long Island, a lot. So let's look at this. So also not showing much snow apparently. Because the UK Met is anticipating that there's going to be a mix of rain with this system. You can see 34 in Long Island. Like, you're going to have mixing according to UK Met. So let's look at the GFS model. 6-hour QPF, showing moderate to heavy precip. moderate to heavy. You still have another 24 to 36 hours until 48 hours until the storm. A lot can still change. Let's look at total QPF. So the GFS is forecasting quite a bit of snow, about up to 1.7 QPF. So the GFS is saying that it's going to be a lot more. And if you look at precip type and rate, let's go to hour 54, 60, 66. Heavy snow in New York City, hour 72. Light snow in 78, it should just be ending. Or really ending, yeah. I don't know how likely that is, but so you have a 993 millibar storm right here off of New Jersey. You'll definitely be having very heavy snow. Thunder snow is very likely. So let's look at the winds now. So very strong winds. I mean, look at these winds, 49 knots. And you're having strong winds off of New York City. I mean, look at these winds, 50 knots. You'll be having gale force winds. Strengthening may actually not happen. The storm weakening may not happen. The storm may actually deepen, especially as it goes over the warmer waters. But that is a possibility that it could do that. I mean, since the model is anticipating it, that's definitely a possibility. So let's look at, again, total QPF. It's going to be all snow. And how much are we getting? Based on the 10-to-1 ratio, which is not very accurate if you ask me, it says 13 inches. Let's go to Kuhira. GFS is saying 14. So it's actually anticipating more snow with the Kuhira method. So we could get anywhere from 10 to 15 inches in New York City, especially like not right along the coast, obviously, but like Manhattan, Bronx, especially just west of New York City, where you're not having all the warm influences from the ocean. You'll have a lot more snow. So for New York City, for the 5 boroughs, I'm anticipating anywhere from 8 to 16 inches, depending on where you are. With the general, and I think the average will probably be about a foot. You're definitely going to see about a foot of snow in New York City as of now. If you live in southern Connecticut, maybe 6 to 10 inches. Actually, southern Connecticut, if you live in the Bridgeport area, let me see how much you're going to get. Actually, yeah, Connecticut, you're going to get a lot of snow. I mean, this model is very accurate, the Euro. So now let's look at the NAM Nest. You know, like, usually the better models are the high resolution models because the NAM does a great job with doing these forecasts. I mean, look at this. Look at all this warm air coming in. You do see this, right? You see this warm air coming in. That will mean a change over to sleet. But then suddenly, as all the heavy precip comes in, you'll have dynamic cooling. You know, evaporational and dynamic cooling because of the strengthening of the storm and because of all the precip. So look at this, very heavy precip will be going through. So it's showing heavy snow going all the way into Vermont. It's showing Vermont getting, you know, copious amounts of snow. It's showing snow from New York City all the way through Vermont. But the thing is, in New York City, it's showing that there might be some mixing, especially right around this time period. From about 3Z, so there's going to be mixing according to the NAM. Look at this. See? Sleet, 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 and then snow. So it's showing sleet coming into New York City. Why is it showing sleet? Why is it showing sleet? This is why. Because you're going to be getting an intrusion into warmer air. You see the 30-degree line right there? So you will be having above freezing temps. But it's going to be brief, but you're then going to have well below freezing temps with 100% humidity. So you're going to have most of your precip falling in this region right here. So what are you going to be having? You're going to be having rain or snow or sleet. From what it looks like, I would say that there would be both, actually, sleet and snow. So you'll be having rain probably falling here, falling through much colder air, which will change it to sleet, but then you'll have snow from about here through about here. So this is basically going to be your cloud. So this is your precip cloud, up to about 10,000 feet. So you'll have a pretty thick cloud going up to about 2 kilometers in height. Because keep in mind, during snowstorms, clouds are usually very low, especially during winter systems. You don't have very high cloud tops. And you will have some cirrus clouds, like you can see some. So this is about where you see all this divergence. That's the dew point and the temperature separating, which means humidity goes from 100% and just decreases very rapidly. Look how quickly the dew point decreases. So you have DALR, you have the dry adiabatic lapse rate and the moist adiabatic lapse rate. So temperatures apparently here are decreasing at the, I believe, at the moist adiabatic lapse rate, because there's going to be a lot of moisture associated with this system. In fact, you even see that increase there, right? And you see that increase in temperature, right? Because keep in mind, this is the stratopause right here. This is the tropopause, right about here. This is where you have the tropopause. So look, temperatures start increasing slightly. They stop decreasing and they start increasing, right about here. You're having a slight increase in temps. Because keep in mind, these are the temperature contours. So they're still decreasing, but you see how the temperature stops decreasing? That's about where the tropopause is, or that's where the stratosphere change. Because that's where the tropopause is, right about here. Or that this could all be the troposphere. But let's look right here. As I said, sleet. You have rain here forming. You have snow forming here. Briefly, like you'll have molten snowflakes. Like you'll have kind of like wet snowflakes. Once it comes out of here, they will refreeze. So you'll have. So here's what you will have. You will have regular snow coming down, like the snow that will actually not like bounce or make noise. So you'll have noisy snowflakes from this. You'll have sleet from here, and then you'll have snow. So you'll have a good amount of snow coming down at this time. Even though they're showing that you're going to be having sleet, you're actually going to be having snow mixing with the sleet. Okay, so now let's look at other soundings. So you're still going to be having mostly snow coming down. Let's look at 700 millibars. And why am I saying there's not going to be, because why am I saying there's going to be mostly snow and not sleet? Is because of the sounding. The sounding is showing that you're going to have a brief intrusion of warming. You're going to have a warm tongue that is very shallow. It's a very thin warm tongue. You're not having something like this. You're having a very brief and sudden intrusion into warm air from about here. That's about what, maybe a couple, like 1,000 feet of temperatures in the upper 30s or maybe mid 30s. That's probably not going to give you enough time to melt all your snowflakes. If you're going to have any melting, it will be very brief. But of course, if you have precip formation here, you will be having rain. So you'll have sleet, like a kind of like a, you know what happens when a snowflake doesn't fully melt but then it refreezes? You kind of get a snowflake that is kind of like sleet, but it's kind of like sleet. So it's like a kind of glazed snowflake. I've seen those before, and they make a lot of noise when they impact. So you'll have a wintry mix at this time, but it'll be mostly snow because of very high humidity and like almost complete humidity right here, with temperatures in the 20s. So yeah, you'll be having snow. And keep in mind, if you have full emergence here, and then if you don't have precip formation here, but down here, you'll be having all snow. lapse rates. Very high lapse rate here. Actually, I'm sorry to say this, but 2 to 3 feet, that's actually likely for the Northeast, just not New York City. Yes, I'm saying, when I'm saying 2 to 3 feet, I'm basing it on the Euro model. Let me show you something. As much as I'm saying I'm hyping things, just want to show you something. That's a Canadian, and the European last night was showing that as well. See? Look at that. Close to 3 feet of snow. And I'm using the 10-to-1 ratio, which is not very accurate. The Cohera is showing a lot of snow for interior Pennsylvania. And let's look at the last night's run. You see, I'm not hyping. I'm going with the more accurate models. The Euro does not do precip very well. It does positions of low very well, not so much precip. So let's look at the GFS now, at the GFS ensembles. Precip accumulation, mean precip accumulation. This is what you want to look at. So it's definitely trending a little bit south now. I mean, actually, my bad, north. Yep. So you see how the precip is trending further south? Yeah. So New York City is in the 20s. So see, big decrease in precip, right? So New York City, 1.12 to 1.66. Oops, that's the... Okay. So let me look at mean precip accumulation. This is for 6C. So let's go to hour 24, right? Or 48. New York City was in between quarter and 0.45 inches. So let's look at this model. So a lot less precip. And let's look at the total, how much snow is going to be falling in New York City. See, 1.57 to 1.02. So now let's look at 12Z. See, 1.2 or 1.57. So you see this, right? 1.02, right? Here you're having more. So let's look at snow, right? Let's look at snowfall. You're clearly seeing an increase. So let's look at New York City, averaging 9.8 inches. 9.2, 9.8. Let's look here now, 10.9. So snowfall is increasing now with each consecutive model run. So, and let's look at midnight. So the midnight run was the more bullish one. Usually the best model runs to use are the high resolution models, such as the WRAP. Especially now when you get all the way out here, when you're closer to the system. Usually 24 to 48 hours is when you're more accurate at forecasting storms. So, because if you're not all the way out there, you could be having huge gaps in forecast. So look, right now, snowfall greater than 1 inch. Let's look at 9Z, hour 48, or let's go to 72. 66, okay. Let's look at hour 60 now. So, this is 66 for 9Z, right? This is 66. See, it doesn't show a lot of snow. Hour 60. A lot more snow, especially here. So, let's look to hour 80. Let's look at this hour 72. Which will be 66. And look at that. Further south, heavy snow now encroaching on New York City. The models are trending further south. Let's look at 12 inches or greater. Okay, let's look at 12 inches or greater. $72. Doesn't show a lot. See, it shows this tiny area in hour 15, which would be 66. A lot more, bigger chance. So these high resolution models are now coming into agreement of a major storm hitting near New York City. Hour 78. New York City is outside the 12. These are probabilities of 12-inch or greater snowfalls, 8-inch or greater, on the edge. And these are not totals, these are in 12-hour periods. You will see probability of 12-inch or greater in a certain amount of time. See probability of 8 in a 12-hour period. Let's look here. Hour 78, or 72 for that matter. Let's look at there, which would be hour 66 here. More towards the south. It's New York City is just inside the 8-inch or greater amount. See, you're having a lower amount on the edge and pretty much inside. Let's look at 78, which here will be 72. So it looks like you'll have your greater snows in the interior northeast. Okay, so I was looking at looks like the interior will still be getting very heavy snow. So looks like Scranton, PA. Let's look at 12-inch or greater. So there's like areas just north of New York City be getting very heavy snow, and even showing New York City getting pretty heavy snow. Remember I said last night there'll be an area of white? So everything is coming together for a major storm. So areas here could get 2 to 3 feet, especially in the mountains, an area we have very cold air. You could be getting areas anywhere from 24 to 36 inches. Not in New York City, obviously, but areas north and west, and in the Appalachians, and interior Pennsylvania, northern New Jersey, and especially in the Catskills of New York, 2 to 3 feet is very likely. Yes, the Euro is not accurate when it comes to snow, but it's accurate in terms of position of storms. Why is the Euro most accurate? Is because they are taking more data than other models. They also did a major upgrade just a few years ago. So let's look at the GFS ensembles and look at mean or ensemble precip accumulation. Let's look at Mid-Atlantic. So the models are trending further south. So the heaviest snows looks like will be ensemble members 6 and ensemble members 7 and 2 are the biggest snow producers for New York City. Ensemble member 3 is probably going too much. But you could have something like ensemble member 4 possibly. Actually 3 does look pretty likely. But let's look at type. Ensemble member 3. Heavy snow into New York City. I mean, this is not impossible. This does look pretty likely. So, because here's the thing: as you're having a deepening storm, you'll have a lot of snow bands. You might have a coastal front setting up. A coastal front is where you have warmer ocean air meeting cold Arctic air, which will enhance snow precipitation because you'll have an area of uplift. You'll have more convergence. And you could get a convergence band setting up right over New York City or Long Island or in interior New Jersey. Wherever you get that convergence band, you will have enhanced snowfall rates, maybe by order of 10 to 20%, and depends on how long that band sits over the same area. And that band is pretty thick. It could be anywhere from 30 to 50 miles thick and produce very heavy snowfall amounts. Usually when you have thunder snow, you have them either on the convergence bands or those feeder bands that come off the storm. Sometimes you'll just get them coming, these bands coming in from the south, kind of like in a hurricane. You'll get these spiral bands. In fact, when we were having thunder snow in 2006, I remember watching the radar, and you were having very heavy bands of snow, like band and then light snow, and then band and then light snow. And we were actually having thunder snow, believe it or not, when there was actually lighter snow. Because we were likely in an updraft area, and there was a really heavy band to my north. That was just to my north, and that was the convergence band. That was the convergence band. But even those regular snow bands, even though they were coming in waves, were producing very heavy snow. And with how warm the ocean is now, especially since we're only in the beginning of winter, there's going to be a lot of convection with this system. A lot of thunder and lightning is possible, especially along the coast. So I'm anticipating, well, maybe snowfall amounts will be held down because of lower snowfall water ratios due to warmer temps. You will likely have very, very heavy snowfall rates. Of course, if it was a drier snow, it would be even more. So instead of 3 feet, you might get 18 to 24 inches in New York City, or just north of the city, wherever that band sets up. Because these models are not showing those bands. They're not. Because those bands are extremely difficult to forecast. Even this model is not forecasting these convergence bands. They're not. These convergence bands are very, very difficult to forecast. In fact, tonight, temperatures are going to go down into the 20s. And tomorrow only will warm up into Tuesday, temperatures will only warm into the low mid-30s, and then you'll have temperatures in the 20s. So look at this. You'll be having a northeast wind coming in. So these northeast winds will be bringing in cold air from interior New England. Even in the afternoon, temperatures will only warm into the low 30s. So you'll have snow coming in. So let's look at the HRRR. It's just coming in now. So let's look at simulated reflectivity. Even though they're showing a little bit of snow for Long Island, I don't think there's going to be much snow in Long Island. In fact, I'm looking at from this first system. In fact, I'm currently looking at KOKX, which is my area. There's some moderate rain that's about to come in. I'm at Stony Brook right now. And there's some moderate rain coming in. Actually, the changeover band is very close to my area. The rain snow line is actually right on top of me right now. In fact, the NAM is saying that this rain snow line is literally right on top of me. But that's looking aloft. That's looking up aloft. And they're showing a mix in New York City, so in the end of the precip extends towards central New Jersey, so it's going to be a while before this precip ends. But New York City is about to have a brief changeover to snow, and the rain snow line, like is only about 1,000 feet up. It's about 1,500 feet. It's already all snow. If you go 1,500 feet, it's all snow where I am right now. and the mixing and the changeover line is about 400 feet thick. From 400 feet, you go from all snow to mix. So it's showing the changeover line slowly moving westward and southward towards my area. Where I am, the precip is very light. Well, I'm about to be hit by a heavy band that's coming in, that just passed through Hicksville, and it's now heading towards Huntington, and it's moving northeast right towards Stony Brook. That is probably the changeover line. Correlation coefficient. Okay, so let's look at this again. So here's your system. Here's your storm that's forming. That is the major. That's the storm that's forming. 1,010 millibar low, right? So let's look at 12Z, right? Same system. 2012. So about the same, no difference really. So you're gonna have a strengthening system coming in. So what time will this be on Wednesday? That would be about 9 a.m. in the morning. Actually, 10 a.m. in the morning. That's 10 a.m. because keep in mind, 14Z. Actually, that's 9 a.m. in the morning. 14Z minus 5 hours would be 9Z. 14 minus 5 is 9Z. 14 minus 5 is 9. So that's 9 a.m. in the morning, local time. So that's Greenwich Mean Time, which means locally it will be 9 a.m. So 9 a.m. you would have overcast conditions. Wind gusts, you would have a light northeast wind at about 12 miles an hour. 10 mile an hour winds, but light northeast winds. But the system is going to increase. It's going to get strong rather quickly. It's going to really increase quickly. I mean, look at your temperatures. Look what's going to be happening. You'll be having cold air coming in with that northeast wind. Look at these temps, guys. Look at these temps. Oh my God! Look at these temps. No way. Those are crazy cold temps. And this will be percolating in to the New York City area. So look at these crazy cold temps, and look at this. You're going to be having a strengthening system here. So you're having, what's going on is you're having a phasing. You're having basically what's going on is this. So let's go to the southeast, right? So you're having a cold front that just came through, right? This is what happens with tropical systems. So you're having a stationary frontal boundary right here, basically. So you're having a northeast wind here, you're having south winds here. So you're having a stationary frontal boundary forming over temperatures that are in the mid-70s. Look at that. So you kind of have, and then you have some enhancement because you have a high pressure system building to the north. You have another low coming in from the south, and this high pressure system weakens right here. So see? So right now you're having this storm system that's leaving, right? It leaves behind an area of lower pressure in its wake. Right here you could see a little bit of spin. North winds here. You're having east winds. So you're definitely having a bit of spin. And then look what happens. Your winds quickly shift from the winds go from northwesterly as a high pressure builds in. The winds quickly turn around and go from the east. We're having east winds here. You're having north winds here, so you're having these winds here. You're having south, and look what happens. A low pressure system forms, and it quickly goes up the coast. So basically, and how do you check if it's a low pressure system? Look. See, cold front comes through. Winds shift. Look. I mean, north winds, they quickly become easterly. And look what happens along the coast. A low pressure system quickly forms. Well and ahead of this system. But usually what happens is these are how coastal storms form. So you'll have these disturbances. It will leave behind a lower pressure, and so this system will transfer its energy to this new low along the coast. So see how it just merges perfectly. And this new low pressure system will merge with this old one, and you'll have a phasing event. You'll basically have phasing going on. And look what happens when you phase. When you phase, you'll have all this enhancement of precipitation. So you'll have a big time enhancement. Even when this low isn't that strong, you see 1,008 millibars, but you already have major enhancement. And this model suggesting that, look, that this system may go inland. It may try to go inland, which depends on how far west it goes, could actually push some of these warmer temps further north and westward, which will mean that there might be less snow, actually. See this? Let's look at precip type. So it depends on where this low sets up. If it goes further north and inland, you'll have more rain. Further east, it'll be all snow. So all that matters is where does the surface low go? Does it go west? Does it go east? And also you'll have some cold air damming here, so you'll have freezing rain and sleet. And what does NAM-NEST show? Oh, look, the 6Z NAM is now coming in. The NAM, the 6Z NAM, the 12Z NAM showed this. See, it showed something similar. It also showed so it showed something similar, basically. Let's look at precip type. New York City could still stay on the snow side of things. In fact, this model shows it's going to be the snow will just be starting at this time, which seems pretty plausible. So so this would be 18Z according to the HRRR, while the NAM has it at the same time for the 12Z run. The NAM 3KM has it here. 1,008, 1,006. You have 1,006 here, right along the coast. While so similar, showing a weaker system though. This is tomorrow, at this time, tomorrow. So nice weather. It'll be kind of chilly outside. Temperatures in New York City will be in the low 30s tomorrow afternoon. So low 30s there, 35, 36. And look what starts happening. See, this cold front leaves behind area of lower pressure, so you have a Coriolis effect right here. Look what starts happening. I mean, you have pressure gradient force, Coriolis force. And look, you get an area of spin. See, as the area, so you'll have south winds here, and look, you get a spin. You'll have cyclogenesis going on here. Look, right there. The area of lower pressure is starting to rain. But keep in mind, this little system that's going through here, just giving us some light rain, is dragging behind a cold front, which will actually set the stage for this major storm that's coming up on Friday. Tomorrow, on Wednesday. Long Island should be getting anywhere from 8 to 12 inches. Weather tracker, I think the Weather Channel is more accurate. The local meteorologists are trying to put their cards on the fact that there'll be warm air coming in. Local meteorologists, they don't like hyping, so they try to underplay the situation. They're trying to go with the with the model that's producing the least snow. Why? Because they want people to basically just know that there's going to be snow, but they don't want people to panic. So that's why they're saying that there's going to be not that much snow. So they used to hype things a lot. I think 12 to 18 inches is kind of too generic. Here's what I think it's going to be. Depends on where you are in New York City. For example, if you're at JFK Airport, you're definitely not getting 12 inches. You're probably going to be getting 8 to 10 at JFK Airport. But if you're in the Bronx, you might be getting 18 inches. So it's going to be more like across most of New Long Island, places like Central Long Island, which includes Brooklyn and Queens. Keep in mind, Long Island includes Brooklyn and Queens geographically. So Brooklyn, Queens, Nassau, Suffolk. If you're on the east end of Long Island, you're not going to get that much snow. But if you're in southern Connecticut, you're going to get a little more. But if you're in Pennsylvania, you're getting thumped. You're getting dunked on. Depends on where in PA you are. If you're in interior, southern, central Pennsylvania, areas like Harrisburg, Lancaster, Allentown, Scranton, Hershey, Pennsylvania, all these towns along I-78 in Pennsylvania, you're all getting dumped with snow. I mean dumped. Allentown, Reading, Hershey, Carlisle, Chambersburg, all this whole area here, this entire area in central, especially in central PA, Altoona, Somerset, basically in the mountains here, you'll be getting 2 to 3 feet. Areas like York, not as much. Lancaster, actually, areas like York, PA. Let's see how much York is going to be getting. A lot of snow. Just let's say about 18 to 24 inches. So basically, the heaviest snows will be falling. Try to look at other models. More across central Pennsylvania. These areas here. So Harrisburg, Hershey, going to Allentown, and between Allentown and Wilkes-Barre, big snows. So Elizabethville will be getting huge amounts of snow, 2 feet about. Graz, and especially these mountains here. You see all these terrain. You see this terrain here. So the higher terrain is going to get a lot of snow, especially because the terrain will actually enhance the snowfalls. So Carlisle, maybe not too much, but areas. So Huntington, Pennsylvania, Huntingdon, Pennsylvania will get a lot of snow. So Uniata College in Huntington should be getting, I would say, about 2 feet of snow. Depends on where, of course, the core of the heaviest snows go. But Chambersburg, big snow coming for you. Big snow. 2 feet plus for you. New York City, let's see. Trying to do hyperlocal forecast. State College, 12 to 18 inches. Because you're in central PA, You might be on the northern side of some of the heaviest snow, so State College might not get as much as areas just to your south and east. Let's see what that is. So areas like basically these areas here: Chambersburg, Hagerstown, Carlisle, Harrisburg. Lancaster should not be getting as much. Lancaster should be getting 12 to 18 inches. Philadelphia should be getting 6 to 12. Trenton, 6 to 12. New York City. Let me look at the model again. Yeah, about 6 to 12 inches. Actually, Philly, I actually have to put you in the 4 to 8 range because you might be getting a lot of mixing going on. So let's look at that cyclogenesis again. So there we go. So you're having a very strong area of high pressure, which will pull down a lot of cold air. Look at all this cold air that's coming in. So Tuesday afternoon, temperatures in the low 30s. So this cold air aloft, look what it's going to be doing. So let's look at the PNA. So PNA is going to be going positive, and then it's going to be going neutral, and then some models are saying negative. So let's look at the Arctic Oscillation. It's going to be negative this entire period, and let's look at the NAO. Oh no, it's not going to go positive. It's going to stay neutral to negative. So December is going to be very stormy, guys. I mean, a lot of storms coming up for December. Until the NAO goes positive, we have a lot of potential of seeing big storms, especially if the PNA goes positive and the AO stays negative. You'll definitely have potential for more storms. I mean, look at this. Another potential here. Some potential here too. Look at this. And definitely potential here. So the month of December should be very, very stormy for the United States, especially the eastern seaboard. I mean, and look at that. Look at all that cold air coming in. If the AO stays negative and you go deeper into winter, you will have the polar vortex coming down into the United States. Negative AO means the collapse of the polar vortex. It means it's not going to be stable. This is not a good pattern for winter. If you want a warm winter, you do not want a negative AO. You want a positive AO, which is a stronger Arctic oscillation, which means a stronger polar vortex. The weaker the polar vortex, the AO will be negative. And a weak polar vortex brings you will actually bring the polar vortex into the United States. Look at that. That's the polar vortex coming down. That's right there. Let's look at North America. That's the polar vortex. You see this right here? That's the polar vortex. But look how it's breaking up constantly. Look, it's not staying together. It's breaking off into pieces. And look what happens. Look at that. A piece of the polar vortex, bam, coming right down into the United States. And when you have a piece like that coming down, you know what happens? You get a storm. Get a major storm. And that doesn't look like it's going to bring a lot of snow, but it's going to bring very cold air in its backside. Look at this. But it's going to bring a lot of snow to Maine. So yeah, very stormy month, especially coming up. But a positive PNA is not good for California because it's going to be drier weather. So southern LA not getting much precipitation. That's not good. But that's only one possibility, by the way. And this is the first day of winter right here. So even before the first day of winter, we're getting already our first major storm of the season. Even before the first day of climatological winter, we're already getting major storms. I mean, I remember in 2010, the first big storm was around December 27th. Yeah, January and February that were very stormy. And of course, that was because of the sea surface temperatures. Delaware County, just west of Philadelphia, should be getting about, I would say, 6 to 9 inches of snow. When I say 2 to 3 feet for the Northeast, I'm not hyping this because there are going to be areas that are going to get that much. There are definitely areas that are going to get 2 to 3 feet. All right. I definitely need a map. Okay, so the NAM is coming in now. So let's look at the phasing. Let's look at the formation of that low. There we go. The formation of the low. Its position and timing is impeccable for precipitation forecast. Look at 12Z compared 12Z to 18Z. Having a little more cold air. So let's look at the position now. Let's look at the southeast. So okay, 2014 right here. So let's look at 12Z compared to now. So this is 1012. Showing a slightly weaker system. Let's look at 920. Let's look at 850 millibar temps. So let's look at continental U.S. So a little more cold air in place. Yeah, a little bit more. So a little bit colder off, just a tiny bit. Let's look at New York City. Okay, New York City. See the coloration? About -5, -5 to -6, and yet for the 18Z, you get the -7. So it's a little colder with this run right over New York City. While this run, about -5. So you have colder air that's coming in. In fact, let's compare 12Z to 18Z. It's about the same, but just a tiny. Okay, let's look at the southern extent of the 850. All right. So a little bit further south. So you're having more cold air in place. So let's look at the southeast again. We'll look at 925. Let's look at 12Z. 12. So you're having a little bit further south. Alright. So I will not be streaming from my computer like this. I will be instead recording with the phone, because I will not be taking my computer to New York City. I will be leaving this computer, the desktop here. So yeah, this should be phasing coming in with this. I'm trying to see the amplification of the 500 millibar trough. Let's look at continental. It looks like it's amplified a little bit stronger here. See here how it's amplified very sharply. So there's still a chance that this system could be a rain event actually in New York City, according to this run. Let's see what happens. Let's look at the 12, 60. See, 6, 12, 12, 18. So you see how this system is here, and yet yesterday the system was further south and the amplification was different. So now you're having a different amplification yet again. So let's look at the flow at the surface. A southwest flow here. So no real change, but look what happens. So this will be the storm coming through. Because if you get say you get this low to tighten up and go up here, your low surface low will automatically go inland. So this is very important to watch. I mean, look at this. But you do see a zonal flow here. So, but you do see a sharper southwest flow here, right? But you do see a sharper move to the northwest here, right? Let's look at 700, right? But you do see also cooler temps down below. Look at this. And where does the warm temps come from? Right here. You see this right here? But you see it's a little bit colder on the surface, but you've seen this warm air starting to intrude, right? Right there, boom. You see that, right? You see this system right here, right? I was trying to go directly north. So there could be, according to this NAM run, warmer temps aloft, especially in New York City. So let's see what's going to happen. This does not look good if you want a lot of snow. So warmer temps coming at the 500 millibar level. So look at that. Boom! Warmer temps. So, but let's look at the surface. Let's look at it 850, right? Six, 12, and 18. So right. So about the same. Things don't look that much different. But the 500 looks a lot different. Look at this. It's a huge difference. I mean, look at this. In fact, look at all this warm air coming in. Wow. Right? So this likely means the storm will end up coming further north. So about the same position though. Mid-Atlantic. Actually, let's get Mid-Atlantic now. So about the same area though. In the 1410. So it's a little bit further south. Nope. A little bit further south. A little bit colder, so let's see. Warm air is about the same area, so it should probably be about the same. Come on, load already. Let's look at other stuff now. We've got another model. Let's look at earthquake activity now. I'll get back to winter weather. Let's see. Nice earthquake near. That's a volcano. It's actually a volcano. It's well north of Iceland. That volcano is called Jan Mayen. There's a volcano right there. It's a volcano. Berenberg. 1985 was the last eruption. Oh, you're gonna see lenticular clouds because, or waveform clouds, or as some people like to call them, spaceship clouds because of this mountain. The flow over this mountain is causing these striations there. Okay, let's go back at last time it erupted. It is the most northern subaerial volcano, active volcano. Basaltic lava flows with minor amounts of tephra. Still fissures. Yeah, it's definitely along the hot spot. I mean the rift. So let's look at the. Let me make sure my microphone is on. You have got to be kidding me! I was muted the whole time. Oh God. Guys, I'm really sorry. Alright, now let's. Alright, I've been waiting for the NAM to come in. Basically, I guess everything I've been saying now doesn't really matter. Oh my God. Okay. For instance, it's a 6Z run, so you can't really trust those, but still. Colder air. Let's see, 0Z. Let's see. A little bit colder, just a tiny bit. Let's go mid-Atlantic. But a significant amount of warm air coming in. Yeah. Warm air. But less warm air, but it's showing more at 850 now. It looks a lot like yesterday's run. So there you'll be having all that cold air. That's dynamic cooling right there. Like boom. So will there be any sleet? Yes, there will be some sleet coming in. But because of the strengthening of the storm and the fact that you'll be on the north side, that warm air will be very brief, which means any snow that comes down, any precip that comes down, will only change over briefly, as you can see. Yep, looks like snow for New York City. Where do they give me? That's pretty high elevation. That's definitely north of New York City. Juniper Valley Park. Oh yeah, that's right. Oh my lord. Not sure how the winds be. Let's see when we're gonna have. Blizzard conditions in New York City. Oh, great. It's time to issue that blizzard warning, guys. Oh my god. Yeah, you can't trust the 18Z, of course. It's a little further south, which means a little bit colder air coming in. Look like Kohira. Jesus. Incredible! Whoa, this is crazy. Look at all this cold air, and then so okay, there you'll be having some sleet coming in now, right? Look at that. Remember, look what starts happening. Look, okay, you'll be having cold air starting to and you'll have this sleet coming in because of the warm air. Because the precip will be so heavy, you will quickly have it change back into snow. It's through a process that meteorologists say, oh, it's bright banding on radar. It's shown as bright banding on radar, but it's known as evaporational cooling. Basically, the precip will be so heavy that will not only cool down the atmosphere, but this evaporation, condensation will be cooling down the atmosphere. So let's look up what dynamic cooling is. When strengthening storms produce upward motion, heavy precipitation that cools the atmosphere. Yeah, this is what you need to read. This is what's going to be happening. When there's a lot of upward motion on the northwest flank of a storm. And where will we be in New York City? On the northwest flank of the storm. Right? We're on the northwest flank of the storm. And guess what that means? A lot of snow. Yeah, that's what the NAM is showing. But let's look at NAM Nest, right? More accurate model. Simulated reflectivity. Yeah, but you'll be having a bit of a dry slot coming in. Look at that. That's a dry slot coming in right there. Precipitation type. And why will you be having snow when you have... Because look, you'll be having less dynamic cooling because look, precipitation gets lighter. Right? But here's the thing. Simulated reflectivity, right? This is usually more accurate. So you'll be having a brief heavy burst of snow. Maybe you'll mix with some sleet. So you won't be having that much snow though. It'll be very quick and heavy though. So look at surface temps. And why will we not be getting that much snow? Because the low will be so close that the forcing will be more to the northwest of the center. So yeah, so inland locations will get a lot more snow. You know, this transpires. Total precip accumulation, let's look at that. You see this V shape right here? That's because you'll be having two areas of very heavy precip. Simulated reflectivity, right? You'll be having one area to your west of heavy precip and one area to your east. To your west and to your east. You'll have two areas of heavy precipitation. So the center of the storm will be very close to the coast, though. And if the storm ends up going further south than expected, further south, simulated reflectivity, look, you'll still have more heavy precip coming in. You see this right here, right? As the system will be pulling west or pulling east, now I'm trying to say that you'll have more heavy precip. So precip type. New York City almost never really sees a change over to sleet. Maybe just a little bit. See how the NAM is saying sleet, snow, sleet, snow? That's because the NAM is saying that there's going to be a lot of mixing. So you'll definitely have a lot of heavy snow. In fact, with all this moisture, once it hits the water, you'll have a lot of moisture just plowing westward. And especially with all this Gulf moisture and all this forcing, you'll likely have very heavy precip. Look at this, all this Gulf moisture, all this tropical moisture surging northward, especially with a warm Atlantic Ocean. Let's look at sea surface temperature anomalies. This is why actually might be some mixing. Look at how warm the Atlantic is. All this moisture is going to surge into the storm, and with all this cold air coming in, you will likely have more snow than forecast. And in fact, during the February storm, let's look for February. It was early February, right? You were having pretty warm waters, but you were having cold waters too. So, beginning of February, here's how the conditions were. So a little warm, so the Atlantic was definitely in its warm phase. But we're not in the warm phase we're not in the cool phase right now. We're definitely in the warm phase. So these departures are from normal, based, I believe, on 1981-2000 levels. So let's look at how warm everything is. The entire Atlantic Ocean is just very above normal warm. So you're having La Nina cooling here. But most of the ocean, look at this, most of the ocean is very warm because of global warming. So there's significant warming going on globally right now. Temperatures are, the coolest waters I'm finding is right about there, around -3 degrees below Celsius, -3 Celsius below normal. But the warmest areas I'm finding are at least 5 degrees Celsius above normal. And there's several areas that are 3 to 4 degrees Celsius above normal. In fact, here, you can't find any waters that are cold waters that are purple. Very little, like it's almost non-existent. This La Nina isn't really cooling down most of the Pacific. It's only cooling down this little region right here. This is nothing like what we had back in 2010. Look at that, Boston. Quickly changing over to snow, even before the 32 degree line crashed in. So usually you'll see snow only south of the 30 degree line, but look, or north of it, but look at that. So right now, where I am, I'm getting a mix right now. Bridgeport is getting all snow. So I'm looking outside right now, even though they're saying there should be some mixing going on. There's very light precip right now. It's mostly in the form of rain. So, no snow today. And in fact, I didn't see any snow. It was all rain here. Okay. So the light rain we're getting right now isn't doing much, you know. Yeah, so this little shower that's coming through will actually become a major blizzard because it's zipping along. It will become a major blizzard in Newfoundland. Boom. In Newfoundland, look at that. Look at the phasing. Wow. Actually, let's see what they're trying to show us, okay? North America, right? Look at that for Newfoundland. Wow. 940 millibars. So snow should be ending by 12Z Thursday. Maybe as late as 18Z. I mean 15Z. So let's look at Mid-Atlantic. Boston's gonna get buried. Oh my lord, Boston's gonna get buried. And how do I know? Look at Cohera. Cohera is a more accurate method, and look at that. Boom. Oh, total. Boom. Let's go to Mid-Atlantic, Northeast. No, Mid-Atlantic's better, right? Shading for 16 inches of snow. Look at all this snow. Incredible. And this isn't because it's going to be cold. It's the... Okay. In fact, the NAM is showing all this warm air coming in. It's showing dynamic cooling. In fact, the only thing the NAM is saying is that you're going to have less precip. Look at that. See? Why they're not showing precip on the north and west side? Why are they showing it all the way up here, right? But, see? Well, the same duration for everybody. The longest area, let's see, total precip accumulation. See, they're showing a bit of a dry sense. Looks like Philly's not going to get much. Because in Philadelphia, even though you're going to get less precip, you're going to get very little snow in Philly. Because you're going to have, like, very low precip. So, let's look at the NAM Nest. I think that's more accurate. Looks like Philly will get a few inches of snow. Definitely. Philly's definitely going to get snow, but depends on how far north or south the system gets, will determine whether it's going to be snow or sleet, or whether there's going to be any mixing or a lot of mixing. And the quicker the storm strengthens, the faster the air will cool down, because with faster strengthening, you get more dynamic cooling, because you'll have more evaporation, more uplift. You'll have more air rising. The faster the air rises, the cooler the upper atmosphere, the cooler everything becomes, because of condensation, evaporation, condensation. Rising air, when air rises and condenses very rapidly, not only lowers temperatures, but not only lowers pressures, but it also lowers temperatures aloft. And during snowstorms, that translates down to the surface. And also, if you have low dew points, with warmer temperatures, falling precip also cools down the atmosphere and the environment as well. So that's why this system is very dynamic, and this model is trying to hint that there will be dynamic cooling. This is why these short-range models are better than models like the GFS, which do not really forecast dynamic cooling very well. They try to, but they don't do a very good job with it. The GFS is showing that the heaviest of the precip will pass right over New York City. Look at this. It's showing Boston getting very little precip. It's showing the rain-snow line being well south of the city. It's showing Philly getting a lot of snow. It's showing everyone but Boston getting a lot of snow. It's showing Albany, which was the NAM was forecasting 2 feet, to get nothing. So which model do I trust more? I go with the NAM. I go with the NAM nest. I go with the strep plumes. I do not go with the GFS. Because look at this. I go with the NAM because the NAM is a lot better at forecasting. Strep right now is forecasting big snows for the Northeast. And in fact, it was this model that called Winter Storm Jonas when the GFS was saying everything's going to go to the south. It was this model and the NAM that said everything was going to come into the Northeast. These high-resolution models, especially the highest resolutions, are the best, much better with forecasting. Let's look at Mid-Atlantic. So this is where you're having this storm forming. Again, when you have all this forcing coming together, all this convergence, you're going to have a lot of instability. The NAM 3KM was going crazy. The NAM was going crazy, right? But the thing is, the NAM 3KM ends, but here's the thing, simulated reflectivity, right? But just when you think, oh, look, there's a dry spell coming in, everything is over, boom, everything refills and you get more heavy precip on the backside of the storm. Or we're not going to be on the backside, we're actually going to be on the front end of the storm. So you'll have a lot more uplift once this system forms. Depends on how strong it gets. If, say, it becomes stronger than 998, you have a lot of warm air, cold air, you could have the storm bombing out potentially. Usually for a storm to bomb out, you need a lot of jet stream energy. We're not going to have a lot of jet stream energy. We're not. We will have a good amount, but so I think this is pretty accurate. Let's look at the NAM right now, okay? At the regular NAM. This system isn't going to be all too powerful, but let's look at winds. But it will have a lot of wind energy with it. So the National Weather Service may issue a blizzard warning, or a blizzard watch, or winter storm watch, very shortly, in fact. Let's see if the National Weather Service has issued that warning yet. So far, not. So far, it has not issued a winter weather warning yet. Let's look at worldometers for COVID cases. Today is Monday, so it's the first day that everything will be more accurately counted. Yes, and we hit 192,000 cases. The thing is, Texas, not everything came in for Texas. Not all the cities, or most of the cities reported their cases, but here's the thing. A lot of counties in Texas didn't report everything. That's why you had very low counts for yesterday. So New York, not everything came in yet either. You're missing data from Nassau and Suffolk. So look, not everything came in for Queens either. In fact, you're missing a good amount of counties here. Jefferson, St. Lawrence, Cortland, Ulster, Suffolk. So you're still missing a lot of data. Nothing came in for Ulster yet. So they may just combine yesterday's and today's data. Suffolk isn't doing good. So let's look at Illinois. Actually, no. Let's look at Pennsylvania. A lot of data didn't come in. Philadelphia again. No data for Philadelphia. Good. Let's look at Allegheny. Okay. Utah, Kentucky, Washington didn't come in. Utah, Kentucky, Washington. So let's look at I gotta call someone. I'm gonna be right back. Hey Charles, how are you?
Let me, I'm out in the rain. Let me walk into the house and I'll call you back.
All right.
Bye.
Let's see now. So let's see. So compared to this run, this current NAM run here, I mean, it's not the most accurate because it's not using the model data, all the data. The balloon launch data is compiled usually at 6 and 18Z. I mean, 0 and 12Z. That's when the balloon launch data is compiled. Is the 0 and 12Z launches. That's when the balloon data is used. So right now, but they're saying it's going to be a little further south. So it's a little bit further south. So you have a little more cold air to work with, according to this one. Let's look at simulated reflectivity. So you're having heavier precip though with this run, and not only that, but even though it looks like there's a dry slot coming in, it's showing more precip. So there probably is going to be a dry slot coming in. So you'll probably have a heavy precip, and then you'll have things getting light, moderate. Usually these crazy winter storms always have dry slots. It's not coming from the south. Where would a dry slot most likely form? This is where a dry slot might form. But then it'll quickly refill itself. So if you're in the northwest side of the storm, like if you're north of the storm, you'll most likely not have a dry slot. But if you're south or right near the storm, yes. So if it comes really far north, like even if the center is still to the south, it won't have enough time to basically for all the forcing. As the storm is building, you usually have forcing well to the north of the center, maybe 100, 150 miles to the north, usually, or 50, 60 miles to the north. So this is where you'll have the greatest forcing, is to your north and to your west. And this is where you'll have a lot of forcing here, forcing. And then you'll just have regular generic snow here to the north. But your heaviest snowfall rates, let's look at the 6 hour, right? Let's look at 6 hour snowfall. Your heaviest snowfall rates will be to the north of New York City. Look at this. Let's look at 6 hour precip accumulations. So you'll have two areas of heavy precip here south with the rain, and then with the snow, very heavy forcing. So, and if this ends up coming over New York City, say the storm is just a little bit to the southeast, boom, you'll have very heavy forcing. But here's the thing: keep in mind that with these warm temps, because it's ocean, it's very warm, and you'll have a lot of cold air, you could have dynamic forcing, just coastal fronts setting up too. How does that coastal front work? Coastal front forms when you have cold air combining with warm air. Basically, this will kind of show you what it does. Maybe relative, depending on the unique. Yeah, you'll have rain-snow line, or it could be the demarcation between the rain-snow line or enhanced snowfall rates. Yeah. This is and the American Meteorological Society. So these fronts typically develop in coastal waters between 1 or 200 kilometers of the coast during the cooler half of the year when the land is cold relative to the ocean. In the United States, coastal fronts are most frequent in New England, Mid-Atlantic states, Carolinas, and Texas. They're usually during snowstorms. Coastal front development. So let's see where a coastal front would form. Let's do it through temperatures, right? surface temps. Right about here is where you have the coastal front. Right where you have very cold air meeting warmer air to your west. And that's where you would have enhanced snowfall rates because of the coastal front. So let's look at surface temps. You definitely have, you see there's a temperature contrast here, so you'll have coastal front here. You would have one probably here. You'll have enhancement not right along the line, but a little bit to the west. So heavy snow here. You definitely have enhanced precip here, which will automatically cool down the air. So that's the thing. These coastal fronts will enhance the snow near the coast or a little bit inland. Coastal front snow. Yeah. See? Oh yeah, the bomb cyclone. Yeah, that's exactly what the HRRR does. I mean the coastal front. And you want to do frontogenesis, right? Frontogenesis, right? Alrighty, so let's look at mid-Atlantic, right? Frontogenesis, look at that. Look at a really heavy frontogenesis right there. Frontogenesis. Frontogenesis. 700 millibars, right? Atlantic. You don't just want to look at near the surface. You want to look aloft too. So very enhanced snow there too. Very strong enhancement. Just to the north of New York City. And look, yep, definitely verifies. But here's the thing: compared to the 6Z run, storm is further south. And look, you have more snow. Look at that, further south, which means more snow. So things are trending towards a more snowy scenario. Doesn't mean that we're going to get 3 feet in New York City. Probably not. I mean, even the NAM, in all of its craziness, is showing a more normal type storm. It's showing a more modest solution. The NAM, in fact, sometimes people will think, oh, the NAM overdoes it, but keep in mind, it nailed the Winter Storm Jonas back in 2016. It nailed it. The NAM just absolutely nailed the storm, especially when it was less than 48 hours out. Jonas, sorry, not Jonas, yeah. Winter Storm Jonas. Where does it rank historically? Okay. Winter Storm Jonas produced prolific amounts of snow in parts of the east, rivaling infamous snowstorms of, oh crap. Winter Storm Jonas produced prolific amounts of snow in parts of the east, rivaling infamous snowstorms of recent past. Snowfall totals from the storm topped out at near 42 inches in West Virginia, and at least 14 in total received more than a foot of snow from the storm. even know who he is. Thanks so much, Donald. Oh, thanks, man. Oh, what the storm watch just issued. That's pretty accurate. Why isn't my radio going off? Well, that's a Connecticut forecast. Let me turn up the volume.
Highs in the mid-30s. Northwest winds 5 to 10 miles per hour with gusts up to 20 miles per hour. Tuesday night, partly cloudy in the evening, then becoming mostly cloudy. North winds around 5 miles per hour. Partly sunny in the morning. Upper 20s. Northeast winds 10 to 15 miles per hour. Gusts up to 25 miles per hour in the afternoon. Chance of snow 40%.
What?
Wednesday night, snow. Snow may be heavy at times after midnight. Heavy snow accumulation. Windy with lows in the mid-20s. Northeast winds 20 to 30 miles per hour with gusts up to 40 miles per hour.
40 mile an hour gusts. Yeah, they're not going to issue a winter storm warning. They're going to issue a blizzard warning, guys. Let's see. I mean, northern New Hampshire, you're not going to get much snow there. I mean, you're going to get snow, but not a lot. You might get a couple inches. Depends on where in New Hampshire you are. I mean, if you're like north in New Hampshire, I'm sorry to say, but you're not going to get a lot of snow from this. I mean, let's go to continental U.S., and this is pretty likely. I mean, this is who's going to get how much snow. This is just according to one model run. This is just according to the NAM. So there's so many other models to look at. There's so many other models. And let's look at the winds, for example. Will we have blizzard conditions? Abso-freaking-lutely, we will have blizzard conditions. Look at these winds, 40-something miles an hour. These are knots. These are not in miles an hour, by the way. Knots is actually more than miles an hour. In fact, 43 knot winds, 43 times 6,000 feet divided by 5,280, this will be miles an hour, 48. So you're going to have gusts near or exceeding 50 miles an hour inland. Along the coast, you'll be having gusts near 70 miles an hour. You're going to have blizzard warnings being issued, guys. You're going to have blizzard conditions along the coast. And that's even if you don't get much snow, even if you don't have much blowing or drifting because the snow is going to be wet, the fact you'll have blowing snow with such strong winds, you're going to have, heavy snow with such strong winds, you'll have blizzard conditions. Absolutely. The storm, in terms of air pressures, will not be strong, but you will have blizzard conditions. No, the was not. Actually, here's the thing. If you look closely, let me show you something. Simulator for 55, 56, 57. You would think you're going to be getting those bands, but look, precip type. There's going to be some sleet mixing in. So, a lot of that is bright banding than the NAM is anticipating, not snow to that extent. The actual heavy snow will be more to the north. And okay, you might get more on the back side. You see there's more coming in here. This will be snow. But on the front end, you'll have some sleet mixing in. So actual snowfall amounts will be heaviest across Connecticut, southern New York, eastern Pennsylvania, especially north and central Pennsylvania. Southeast PA, especially Philadelphia, I'm on the fence about how much snow you're going to get. But northern New York, like blizzard warnings will be issued, definitely. I have almost 100% confidence they'll issue a blizzard warning, especially by tomorrow afternoon. Issued by tomorrow morning. There will not be a English store. Abilities. Okay, I'm still here, guys. I'm not going anywhere. Thank you for all the likes. For Blizzard One, you need. Alright, so let's look at this now. So let's look at surface visibility. Surface products, we'll be looking at, okay, wind gusts, right? So this is when about the worst of the conditions will occur. So you'll definitely be having blizzard conditions. There's no doubt about that. You will definitely be having blizzard conditions. Okay, so let's look at the wrap now, or the ARRR. I mean, ARRR, it only goes out to 18 hours right now, but let's look at it anyway. So let's look at the southeast. You want to look at where the surface low should be forming. So it's still hasn't really not formed yet. It kind of has as a bit of a swirl right over just off the coast of Florida. So there's a lot of moisture with this storm. It's going to be forming from very warm water. So the system is going to have a lot of moisture with it. And so you can see it's going to have Gulf moisture. Look at all this moisture that's going to be streaming northward. And let's look at 18Z. And so let's look at wrap, the 15Z wrap. So the 21Z wrap should be coming out around 6 p.m. I have to be leaving in an hour, unfortunately. I'm going back to Queens, and I will not be taking the computer with me. I will still be live streaming, but it's going to be from my phone. So it's going to be more unscheduled. So here's what I'm going to do. I'm going to be streaming again tonight. I think you could also schedule streams on your phone. I'm going to see if I can do that. Yeah, so I have your channel. Let's see, go live. Let me see. No, something for kids. Schedule for later. Okay, I'm scheduling my stream for later. This is another stream I'm scheduling. This will be on my phone. I'm scheduling it for 11 p.m. tonight. You know, this one, all the models will be coming in, so I'm scheduling it for 11 tonight. Yeah. Let's look at the 18Z wrap, which just came in. Okay. 18Z, the 21Z should be coming in around 5 to 6 p.m. So let me look at the model again. So there's so many models to look at. There's got the gem. The gem is just coming in now. It's a Canadian. This is the high resolution Canadian. And let's look at total precip accumulation with the Canadian. So let's look at snowfall with the Canadian run. So again, heavy snows. So you're going to be getting very strong winds again. Look at this. Blizzard conditions are definitely a likelihood. So I'm going to make a call now. Thank you for watching, because now that they issued winter storm warning, I can finally make a call to the National Weather Service. Thank you for watching. I don't know why I cannot hear your phone ring. Phone's acting weird.
Hi, Arthur.
Hey, Charles. Yeah, apparently I have my phone on Do Not Disturb. I put you on emergency bypass, but it still didn't go through, apparently. Anyway, yeah, I've been looking at the NAM right now. I don't know. I'm definitely not going with the GFS. It's too far to the south, and all the models are trending north. But a blizzard warning will be issued, definitely. The NAM is showing very strong winds with the storm.
Yeah, I think the NAM is way overdone.
No, not the precip. No, the snow amount isn't overdone. The snow amount.
I think it is in the Boston area. I really do.
Well, here's the thing. The European, I've been looking at other models too, and they're especially the Shref plumes are all showing very heavy snow going north, like southern New Hampshire, getting really heavy snow. Like it's sending all the snow north. This is like what happened back in 2016 with Winter Storm Juno. I mean, Jonas. Winter Storm Jonas. Basically, everything said, "Oh, it's going to go south. It's going to miss," and the NAM and the SREF started bringing in more and more north, and that's what ended up happening.
You know, the Euro's been pretty consistent every day. So is the GFS.
Yeah,
They've
but
been pretty consistent.
yeah, but the Euro brings a lot of snow.
GFS in 12Z was just about where it was yesterday at 12Z. You know, it hasn't gone further south. It hasn't gone much north. And the Euro's a little bit further south.
Yeah, but it's not the position of the low I'm talking about, but it's the precip. There's hardly any precipitation with those runs. With such a strong system, with all this moisture from the Gulf, you're going to get a lot more precip. I think the NAM is accurate with the amount of precip, but not the placement of the low.
Right. Okay. No, I would agree with you on that. Oh, certainly. You've got the whole. It's feeding up from the Gulf.
Mm-hmm.
You've got. Rather from the Bahamas. I mean, you're getting a good feed in there.
Mm-hmm.
Moisture and very cold air. So.
Yeah, it's actually forming like a tropical system on the tail end of a frontal system.
Yeah. The problem is that people should know that the model. Nobody should go with anything until it crosses the Rockies and really gets past the Rockies, you know, onto the plains. Then you can, you know, the models can zoom in a little bit better on it. But before that, you know, I never look at anything when it's that far out.
Charles, do you think the precip is underdone or overdone with the models, or it's just about right?
I think it's just about right, and everything is showing New York City getting some pretty good snow.
No, I'm talking about like when I looked at the GFS, it had very little precip with it for the amount of Gulf moisture. It showed you're in the northwest side of the storm, and it showed very little precip. I'm looking at it, I'm thinking, why is it showing such little precip? Why is the NAM showing so much more?
It wasn't showing that little. It was showing at least an inch.
An inch.
An inch of melted, I'm saying.
Yeah, an inch of QPF, I know.
10 to 12 inches of snow in New York.
The Euro is showing up to 2.
Right. Just north of there, there's some models showing 3 feet, which is absurd.
Here's what I'm thinking. I'm thinking that you'll have as much precip as with the NAM, but it's going to be further south. So I think there's going to be really heavy snows, not as far south as like the GFS. I'm thinking like interior New Jersey might get 2 feet. Southern New England, like your area, might get 6 to 12 inches.
Oh yeah, I think so. I can't imagine it won't. Even if the Cape turned to rain for a little bit, you're going to get the wind shifting to north. The thing that Tim was talking about today, that's positive.
Who?
Is Tim Kelly. You know Tim Kelly.
Oh, where can I watch his video?
You've met Tim on occasions. Tim Kelly,
from TV.
On New England Cable News.
Yeah, but I don't watch New England Cable. I don't have it.
Well, you follow him on Twitter, don't you?
I do, but I'm not on Twitter that much. I'm on Twitter sometimes.
Okay. Yeah, almost everybody I follow on there is weather related on that.
Same.
But what he's saying is that this is not, at least he was talking to me on Cape Cod and the people right in this area. He said, where you run into this big changeover thing is when it runs right up the coast. But this is not doing that. You know, it's basically going right out under New York City and then going straight out a little bit further north, but not much. So it's not a classic where it's going to end up in the Gulf of Maine by any means.
It's not a classic, but here's the thing. Because it's going to elongate itself, you're going to get an east to west arc of very heavy snow according to the NAM 3km. The 3km is more accurate than the NAM because the NAM itself is more bullish. It's more bullish.
Yeah, I've never been a NAM fan, but a NAM fan, a little rhyme there. Okay, well, we both know that tomorrow morning is when you'll really know a lot more. After the 12Z comes out, the OZ rather comes out tonight.
I was actually thinking New York City might actually even get a changeover to some sleet or freezing rain because that's what
it did for a while. It would go right back to snow, so you'll end up with a nice snow cover.
Yeah. What if it is further south? That would bring all the heavy snow, like all the craziness, right into New York City.
It would. You should be hoping for the for the GFS. I mean that gives you more snow than anybody, just about. And then it sort of dies out, and it's me that gets nothing. I mean,
Well, I don't believe that. I think the GFS is underdoing the precip. Here, I'll explain why. Because here's the thing: when you're getting all this moisture coming northward, it's leaving. You're having light precip. You're having only a couple areas of heavy precip according to the GFS. But yet, there's so much moisture. The rain snow line is just to the south of New York City. They're not showing enhancement. So, like, do you have FaceTime?
do I what?
FaceTime.
No.
Because I'm on card.edu right now, looking at the 12Z GFS. It is showing heavy snow over New York City, but it's not showing as much as the NAM. The NAM is showing so much more precip than the GFS is showing.
It's showing everywhere. It's showing 14, 15, 16 inches in Plymouth, for crying out loud. I mean, I think it's overdone.
No. I'm talking about, okay, when it comes in, okay, so before it goes into north of New York City, hour 57, there's a lot of orange and red. The GF, that would be 63 for the GFS. So when I'm at hour 63 with the GFS, it shows very little precip. It shows like moderate precip, and that's about it. It shows moderate precip, moderate to heavy precip over New York. And then you have the low, it doesn't have much, and then there's almost no precip with the low after it goes east. It shows the low is still there, but the precip dies out. But the ocean is so warm.
It might die out a little bit in your area, but not over here. We'll get our north wind off the water. And, certainly on the east coast of, Massachusetts, we're going to be. And by the way, Thursday is the highest astronomical tide in quite a while. I don't know if you looked at that.
Oh, so it's significant coastal flooding.
Very high astronomical. There was already flooding on Marcy Boulevard today. The road was all covered. I don't know if you know where Marcy Boulevard is. You know where the gas tank is that has the paintings on it?
Yes, I do.
You drive in.
Yeah, in Boston.
Yeah, right. That's where Marcy Boulevard is, and it's very low. And now with all these high tides we keep getting, it floods more and more and more. And it was flooding today, so I think Thursday morning they're going to have some water in Boston. Because it's going to be a good wind. You've got a tight gradient. Very tight gradient, strong high pressure north, and I can't imagine we're not going to have 50, 60 mile an hour winds. The models that Tim was looking at today show in Norwood, Massachusetts, or Canton rather, right below Blue Hill, 40 to 45. That's just below, so we're going to get 70, 75 on top of the hill.
You mean mile an hour winds?
Mm-hmm.
So the National Weather Service just issued a winter storm watch. Why didn't they issue a blizzard watch with these kind of winds forecasted? What is OKX thinking?
Because it's way too far out. They're not going to go out on a limb like that. They've already been burned, as I said, 2 weeks ago. So they're not going to do that. They wouldn't issue a blizzard watch probably till just before it on late Wednesday.
You mean warning? No. I remember they issued blizzard watches 2-3 days before the storm hit, and it was crazy. It was a crazy storm. Mm-hmm. This storm is a very high confidence.
Blizzard today means nothing compared with what it really meant when you go back in history. Right now, it just means that it has to be gusts over 35 miles an hour, and what was the other thing? There's only one. There you go. Visibility, 1/4 mile for 3 hours. That's the only thing now, and they've taken temperature out of it, so it doesn't mean anything. Temperature used to be, I don't know if you know this, but it had to be 20 degrees or lower to be a blizzard, and a supreme blizzard, or whatever the word they use, was below 10 degrees. And the key was the wind, and of course, as you know, it didn't have to be snowing either. In the Great Plains, it could be just blowing snow, where you can't see anything for 3 or 4 hours, and gusts over 35. That's a blizzard too.
Yep.
It's a ground blizzard. But now it just doesn't need anything. They seem to call everything Weather Channel. They name what's this one? Sally or some stupid name?
GAIL.
GAIL. Oh my God, give me a break.
No, but here's the thing. They're naming storms. I think that's a good idea. You know why? Because
why?
blizzard of 2010 could mean blizzard of 2010 in New York, blizzard of 2010 in Chicago. There's been so many blizzards of 2010s. It's like, which one? You need to name storms because you're going to lose track of which one caused which. You could say the New York blizzard of 2010, but if you have 4 blizzards, you could say, you see what I mean? It's like hurricanes.
Oh, I know exactly what you mean. The blizzard of 88 actually was in the Midwest too. The blizzard of 78 there was another big one in the West.
Yeah, what about the blizzard of 2010? New York City had 3 blizzards in 2010. Like, that's the thing. I think, like, there should be a winter storm season. You should have winter storms, like Winter Storm Marcus or Winter Storm, But you're not going to call the storm a blizzard. You're just going to call it a winter storm. Like, for the snow part of it. But these winter storms are also very dynamic. They also bring severe weather.
Right. So anyway, my daughter just called me while we were on the phone here, so I've got to call Blair because now she's going to do the same thing you're doing. She'll be panicked.
Why is she panicking?
She wants a lot of snow.
Well, she's getting it. We're getting it. Like, it's happening. Like, I could just.
No, I hope so.
If anything,
I think so.
If anything,
is going to get.
If anything, I'll just take the Metro North.
Maybe a foot of snow.
If anything, I'll just take the Metro North, go to maybe Poughkeepsie, and stay there and see all the snow. If it does end up going further north, like.
She said I'll have to drive over the bridge because that's where the heavy snow will be.
But. or she could just take. I would just take the mass transit because. Well, yeah, probably car is better. I don't have a car, so. Yeah, imagine. What happens if I get lost? Imagine if I'm like in New York City, or if I go north and I get snowed in.
Well, just go out and take some pictures. And, she does that. She does it wonderfully. She goes out.
I live stream.
The snow comes. She's out there in Central Park taking pictures and then puts them on Twitter, or Instagram, or one of those.
I live stream. I'm live. I'm outside live streaming during blizzards.
Well, let's keep our fingers crossed. I got to call her.
Thanks.
All right, bye.
Bye. All right, I'm back now, guys. Just talked to the director of the Blue Hills Observatory. We both don't know which model to agree on right now because things are just so hectic right now. Basically, the best time to forecast when the storm is going to happen is once it gets east of the Rocky Mountains. Once this storm, not this one, but this one, once this gets east of the Rockies, because it's still in the Rockies. So you want to know where the surface low is going to form. Where is it going to form? Where is this low that's being depicted forms? Right? You want to know where this storm is going to form. Is it going to form here and end up, the storm is going to go further north? So let's look at what the NAM is forecasting. See how the GFS has it going over Texas? The NAM has it also going over Texas, but then look what happens. Get a piece of it. You have several pieces of this, and all of this will come together right along the coast. So piece here, piece here, piece here. Everything will join forces and basically be here. The GFS, though, especially the 12Z GFS, have this. We had a stronger system here. This is pretty likely. But then look, north and then suddenly east, right? Right as soon as you hit the Delmarva, just north and east. And where does that eastward turn take place? Does it take place near New York City or well to the south of New York City? If it takes place over New York City, say it goes north and then suddenly veers east. Say it goes north and then goes east. So say you get this heavy snow and it just veers east. What's going to happen is you're going to get heavy snow that will continue basically because you're going to get this front end that will then continue. Hold on, I'll be right back. is my mask? Okay, I'm just looking for. Ah, there it is, my mask. All right. Just want to hear what that sound was. I'm not done with the stream. Oh crap. Same price? So regular buffet price. Yeah. Where pay for carry out food or it's carry it's gonna be the buffet? How is someone gonna say you have to pay extra or no? What about carry out? Okay, thank you so much. Yeah. Bye. Okay, so let's look at this again. GFS is just coming in now. Let's look at surface winds. The surface temps. There you have everything there. Look at this. I mean, just keep in mind this is an 18Z run, so it does look pretty strong. Look at that! Wow. Compare this with the NAM. So yeah, you definitely have a strong low, but then look what's going to happen. It's going to veer north, and then it's going to veer east. So if it's further south, you could get a bigger storm. I mean, not bigger storm, but more snow, because you'll have that forcing area more over New York City. GFS usually underdoes precipitation until right before the storm hits. So usually once you get really close, it usually does better with precip amounts. So let's see. So far everything is going as planned. Everything is going, the way it's been forecasted. So 550, that's 520. Well, 555, 5550. That is 55. Okay, so everything is decreasing in 30s, right? 5590, 5550, 5420, 5490, 490, 5460, and 5430. That's 5430 right there. Should be. See, right there, 5430. So it's showing a little bit of a stronger system. So let's see, 36, right? 5460. So it's showing about the same location, right? Hold on, 36, right? Okay. I mean, basically in the same location, right? So let's look at 925. Okay, so you're having this. Okay, let's look at the surface then. You want to see exactly where the storm is going to form. So, okay, hour 33, right? Hour 39, right? See, a little bit stronger, right? Let's look at southeast. Let's look at how much precip it's going to be. Let's look at continental U.S. because I'm looking at how much precip is falling with this system. So about the same. It was a little deeper actually. A little bit deeper. That's the train. If you heard that. Okay, so 36. Let's look at 12Z. So 1614, so 1614, so about the same, not much difference. These are very similar, a little bit windier there, but the 18Z looks very similar. Look, now look, hour 39, look, already a low forming, look at that. So look, 45, and look, a little bit bigger, so it looks like a little bit of a stronger low. Let's look at southeast, right? That is that's 1,012 millibars, right? Okay. 1,012. 2014, 2012. Look, you have 1,012 there, so it's about the same, not much different. Let's look at Mid-Atlantic. Oops, I mean continental U.S. All right. So things that look pretty similar. So you're having, this is where you're gonna have your convergence. All this Gulf moisture is gonna go north and just blow up big time. You're gonna have big time convection. Let's look at 500 millibar temps. You're having a, so I think the 18Z GFS will bring the system further north. Very strongly, I believe that's going to happen. So look, so you're having 1,012 millibar low right here. I'll be right back. Hi, I have a 6:15, 5:15 schedule pickup Okay, guys, I'm back. So I'm still looking at the system. You see this, right? So hour 63. Oh, look at that. Having a very strong system, right? But again, not as much precip. That's the problem. See, it's extending it further west, but okay, the problem is it's the amount that's in New York City. It just doesn't fit. It just doesn't fit with the type of system you're having. Not only, okay, you're having a weaker system, right? It's not very strong in terms of air pressure, but see how quickly the precip ends? Even though the low pulls away, right? I mean, this could be right. There's a potential that this could actually be accurate. So it is bringing more precip, like 1.76 inches, right? But look, here's the problem you're dealing with. Okay, see, let's look at snowfall again. Okay, 14 inches. So yes, you're dealing with a lot of snow in New York City. But let's look at coherent. That's the one you want to look at. It's the coherent method. 20 inches, right? Okay. Let's look at our, I don't know, our, let's go right about here, right? 12 to 18Z, right? You're gonna have light snow coming in around 21Z, right? About this time you're gonna start having light snow around like 3 or 4 p.m. and so snow will be ending right around 18Z. 18Z, the snow should just be ending. See? Just be ending around that time. But here's the thing. It shows less snow, less precipitation. Okay, right? 63, right? 12Z. So you're having a more precip. In fact, they're actually showing less precip with this model run. It just does not make sense. The fact is, you're having a very dynamic system coming in with all this tropical moisture, and then it just does not make sense. So hour 75, right? It's showing a little further north. Hour 72, right? Let's look here. So it's trying to show more precip backing in. See, it's showing a little further west now. So even the GFS is trending a little further north. So the GFS is trying its hardest now. Say, hey, there might be some heavy precip coming in. But see, it's showing less heavy precip. So it's showing 1, 2, 3. So it's showing how many hours of heavy precip? About from about 6Z to about 12 roughly. To 12Z you'll be having heavy precip, moderate to heavy precip from 3Z to about 9Z. So 6 hours of heavy snow. Really heavy snow. But that's what the GFS is showing. GFS is showing moderate snow, light moderate snow from about 7 p.m. 10, 1, 4, 7, 10. So ending the snow right around around 10 a.m. Or ending this around 10 a.m. Because let's look at simulated reflectivity. Simulated. Come on, where's the simulated reflectivity? This is this is hour 75, right? So the snow will already be ending. So the snow should be ending right around like 7 a.m. So 7 to 8 a.m. is when the snow should be ending, right? And then you'll have all this heavy snow coming in. So this will be around 1 a.m. So 1 a.m. is when you're going to be having the worst of the conditions. You'll have snow coming in right around this time. Keep in mind this is mostly Virgo, right? So 21Z, you'll be having precip coming in, which is keep in mind 21Z, take away 5 hours. That's about 4 p.m. So you'll be having snow coming in 3 to like 2, 3, 4 p.m. and then you'll have the worsening conditions overnight and ending right around 8 a.m. according to the GFS. The NAM, on the other hand, shows this. The reflectivity. The NAM shows precipitation ending around the same time, a little bit later, just a bit later. Let's look at a mid-Atlantic, right? Hour 60. Hour 60, right? Let's look at the GFS ensembles again. Precipitation accumulation. Let's look at hour 72, 78, 84. Okay, let's go to 384. Boom. So it's showing some snow events. So right about here. Around Christmas time. Precip accumulation. Okay, I definitely want ensemble member 7. It's a Christmas Day snowstorm. Ensemble member 7, right? Oh, I'm sorry, no. Yep, look at that. Ensemble member 9, I mean. Definitely want this one. So I'll see the most dynamic cooling is showed with ensemble member 9 and 16. So these are the craziest ones, right? Yeah, definitely want 9 and 16. You know which model I really want? Let's look at ensemble precip accumulation. I would want ensemble member 6 and 3 and 2. I would want 6, 2 and 3. Definitely want ensemble member. GEFS. Let's look at the wrap now. Okay, the 21Z's coming in. Brentwood. Okay, so I'm getting off in about 10 minutes. Okay, let's see. Let's look at the wrap model again. Yeah, we're gonna get a big snowstorm. How much? Anywhere from as little as 5 or 6 inches in New York City to as much as 2 feet. Depends on which track the storm takes. But I am gonna say with good confidence that we're gonna get 12 to 18 inches in New York City. 12 to 18 inches with very good confidence. Why am I saying so much snow is going to come down? The reason I'm predicting so much snow, again, is because, look, you're going to have a strengthening storm. You're going to have all this moisture combining. The Atlantic is way above normal in terms of temperatures. But there's going to be enough cold air that it's not going to change the snow over the rain, especially in the city and westward. So here's the thing. When I mean above normal, not by a lot, but by a couple degrees. So you're still going to have cold temperatures aloft, right? In fact, when the precip comes in, you're going to have a dynamic cooling, from rising air, condensation, precipitation, evaporational cooling. Let's look at surface dew points. 2-meter dew points, right? You got a very cold dew point. I mean, look at these dew points in the 20s, 30 millibar dew points. Again, you got a very low dew points, and so with dew points being so low, especially at the surface being, in the teens, look at these dew points. But even as dew points increase because of Atlantic moisture, the heavy precip will lower the temperature, raise the dew points, as the humidity goes up. See right here, you'll see this increase right here. But look at surface temperatures. Just keep in mind. As precip comes in, temperatures will lower normally, right? And now Nest shows this very well, right? Look at this. So precip comes in, temperatures lower. Look at this. This is because of dynamic cooling. Look at this. Look at this. It even shows it in New York City, and it shows the temperature staying sub-freezing in New York because you're going to be having north winds coming in. You're going to have warm air coming in aloft, a little bit of warm air coming in aloft. Cold air at the surface, keep in mind, you'll be having a northeast wind. And so this will cause you to have some mixed precipitation, briefly. But it'll be largely in the form of snow. So I'm getting off at 10 minutes. Okay, 56, okay, good. It's away, so, okay. Oops, I see that as Okay, guys, I'm gonna be leaving in a few minutes. Anyway, the wrap is coming in now, and this is the long duration wrap. So this is the one that will go out up to hour 51. Okay, I will be streaming again at 11, so once the stream ends, I will be joining at 11 o'clock. So 18 to 24 inches looks like a good bet. Why am I saying that there might be 18 to 24 inches? Why? Because of all this Gulf moisture. Look at this. So you're going to have all this Gulf moisture coming in. Even though the GFS is not really showing all this phasing and precipitation, look at this white disconnect. Look what the GFS is doing, right? So let's look at the European, right? Let's look at, because I'm paying a lot of money for these models, right? Let's look at the EPS, right? So let's look at, so this is earlier today, 24, 48, 72. Look what the EPS is showing. 1,000 millibar low right there. Look at this. I mean, look at this regional. So you're having a 1,000 millibar low. Look at this. 1,000 millibar right there, right? And yet the European ensemble is showing something similar, right? But it's showing a very strong low. Let's look back at the ensembles, right? 96. So what is this? This is Thursday morning, 12Z. This is Thursday morning, showing a pretty strong low here. And it's showing temperature anomaly, showing cold air over New York City. So it's showing everything being basically conducive for a major storm. And that's what the operational is showing. The high resolution European, the high res European is showing this. It's showing 1,000 millibar low here. But the thing is showing, showing a strong system. Let's go look at regional. Let's look at Mid-Atlantic. So, this is 12Z around the same time. Precip type and rate. So, again, this time you'll be having very heavy precip. And European, a lot of these models are having issues with precip. So, you'll probably already be having snow this time. So, look, 60, 62, 78. So, let's look at total QPF. Well, 1.7. So it shows the least amount of snow right over New York City. That's something I definitely do not want to see. But let's look at the NAM 3KM Con US. Already the NAM is already showing pretty heavy rates of precipitation. But the NAM is also trying to show this lack of snow. Look at this. Already 8 inches from the NAM, right? Okay, I gotta be going now. I'll make another update at 11 p.m. Thank you all for watching. Have a